Hello. In this video, we're going to go over the mutation, deletion, insertion, substitution activity. So the first thing we're going to do is we're going to look at the practice notes, and we're going to use those practice notes to learn how to do the mutation practice. So here's what the practice note activity looks like. So the practice note activity looks like this. So this will take care of doing some of your worksheet. So let's look at your worksheet. So this is the activity, and this is your practice. And so by doing this practice, you'll be taking care of this one, this one, this one, and sequence 5, I think it is. So you can, just by attaching this, you'll be able to do those, and then you'll do the rest of this by yourself. All right, let's get started on this. This PowerPoint will go through each of these different sections on your mutation practice notes. So again, you should have that in front of you. So first off, we have this original sequence of DNA, and we need to make it into mRNA and then into an amino acid sequence. So we have to remember Chargaff's rules, which you may not have even heard of. And Chargaff was the scientist who actually figured out the DNA sequences, or helps figure it out, and he found out that the ratio of cytosine and guanine were exactly the same, and so cytosine must always bind with guanine. And he also found out that the adenine-thymine ratios were exactly the same, so they were the same but different than cytosine and guanine. So the amount of adenine was always the same as thymine, so adenine must bind with thymine. So we start off with, okay, well, if we have a T, that means that it must bind with an A. So if we have T here, we have to have A here, right? And then in original DNA, if we had an A, we would have a T. But something else you might remember is that in RNA, there is no thymine. So we can't have a thymine here. We have a uracil. So A binds with U. Okay, and then we have our C. And again, our C always binds with G. So we would have our G there. And then we have our A, and our A should bind with T, but because we're in RNA, it must bind with U. And then we have our C. We already know that C binds with G. And we have one more C, and we know it binds with G. So one other thing I didn't go over is it's always good to break these into threes, kind of. So you can, I would do is possibly draw a line, break your DNA sequence into threes. 1, 2, 3, draw a line. 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 And 1, 2, 3, draw a line. So every 3 is going to be your sequence, because RNA then is transcribed into an amino acid sequence. So these turn into amino acids. So let's go ahead and look at that. And we did that last week. So, but before doing that, you need to stop and finish the sequence out. So go ahead and stop this video and finish that out. Then we'll move into the RNA. So last week, we did the RNA, we did the amino acid sequence from your RNA. So you might remember that all you have to do is take this and put it into your codon chart. So you can look this up online if you want. You can try to use this one. It's a little bit fuzzy because I blew it out of proportion. So AUG, so we go to our A, we go to our U, we go to our G, and that is methionine. So again, you can find these charts online really easily, so you can just pull one up. Right? So our second, right here, so we go to our U, we go to our G, and then our next one is a G, so that's tryptophan, and then our last one, C, so we go to our A, we go to our A, we go to our C, it's asparagine. So you can go ahead and stop this video and finish doing these. You should already have this done, and then fill this out using the chart. Start the video when you're ready. Okay, so now we move on to our next practice, which is sequence 1. So again, what I would advise doing is separating this into threes. So separate your DNA sequence into threes, and I've already kind of did that for me. by having lines drawn down every 3. So 1, 2, 3 line, 1, 2, 3 line. Okay, then you go ahead and we're looking for a difference. Okay, so this DNA sequence has been mutated from this one. So the easy thing to do is just look to see where it's different. So these are all the same. ACT. Oh, here's our difference right here, and everything else is the same. So I know that this is my one difference. Everything else is going to be the same. So the first thing we need to do is highlight the change. Okay, so you take your highlighter and you highlight the change. All right, so it is now a T, and you go ahead and you do your sequence, which is, here's our first one. Now here it changed. So again, we started with U, but now it's a T, so this is going to be an A instead of a U, and then we have our, instead of a G, and now we have our G, and then everything else will be the same all the way down. All right, so here, this is all going to be the same except for this one right here. So we'd have our methionine, but here instead of, we're going to have a stop sequence. All right, so everything else can stop from here. You don't have to write anything else down because this is going to be a stop now. All right, so now we go to what are the effects. So on your original worksheet, we have this information that we're going to use to answer the effect, what kind of deletion this was. So we look at, well, it was frame shift deletion, a base is lost or deleted. Well, it wasn't lost or deleted. Insertion, extra base added, so no. So this must be a point mutation. All right, something was mutated at one point, which it was. We had this changed at one point. So substitution changes the amino acid. It's called a missense. Well, that happened, but substitution does not change. No, it definitely changed. Substitution changes the amino acid to a stop sequence. And that's what happened. There's a stop sequence. It's called a nonsense mutation. So here's what our thing might have looked like. In this sequence was coding for wings with spots on it. Well, would there be an effect? Yes. If we stopped the sequence, then this feature would not be made at all. It would just be stopped. So it might look like this now. All right, so was there an effect? Yes. And this is called a substitution. And it was called a nonsense substitution. So you would go ahead and fill that in based on this chart. So again, because we stopped, we didn't make the protein at all. If you're not making the protein at all, then this isn't going to happen at all. And so the wings are not going to form. Okay, let's go on to our next sequence, number 2. So again, divide this into 3s. Okay, and then you're going to look for the difference. All right, so here was our original sequence from the top. And so this is the same. And this, oh, it's totally different. So we got a change here, got a change there. Same, 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 same. So this is changed. All right, so we have a point mutation again at 2 different points though. So we highlight the change. So we have a change here, and we have a change here. So we highlight the change. All right, and then we go ahead and fill in. So this is the same, but this is different. So G is coding for C, T codes for A, C codes for G, and then everything else is the same. So go ahead and fill out the rest of that for the same. And then we go ahead and go, okay, well, this is methionine. Well, this used to be a stop sequence, but now if I go to my chart, CAG, CAG, it is glutamine. All right, so I have a new, and then everything else is the same all the way down. So how is that going to affect things? Again, you can stop this video if you need to fill these out. Well, first off, will it be affected? Well, probably. All right, so here's our horse. All right, and what happens is because we have a different sequence, met glue sir, met pro sir, so this is changed from here. Instead of having this, we have this. And so it's a different protein, it's going to have a different shape, might interact differently, so it's going to code for a different effect. So yes, we totally have an effect. And what do we call this? We call this a substitution because it was substituted, but it was a missense because it didn't code for a stop, right? So that's how you fill out this, all right? So you can go ahead and do those. Now we can go ahead and go to our last sequence, which is sequence 5. So on your chart, we did not do the next one. We jumped to sequence 5, so go to that. And the first thing, again, you do is you go ahead and you mark off your 3s. All right, and this is our original. So in this case, we have this is the same, this is the same. Well, I shouldn't say it's the same. It's different from the other one, but it's the same as the ones that we've been doing, all right? So here, the same, but then, wait, we lost a C. Our C is completely gone. So this is a deletion. So we highlight the change. So here, you're going to put a highlight between the two G's because that is completely gone. It is no longer there. All right, so how's that going to affect things? Well, all right, we had this sequence going on, but now everything is kind of shifted over. So here was our original sequence way back when, all right? And because this is gone, all of these things shift over one. So what will happen is, so that's gone. So now here's our lineup, all right? So we have our TTG, and that's just still our TTG, but now this is going to be shifted over. So there's our new 3 codons, and that's going to be totally different than what's originally. And here's our next 3 codons right here. That's going to be totally different. And then we're left off, and then there might be another codon coming down, and that would make a new thing here. So these are all going to be completely different, right, than originally. So this is what we were having when we had our purple wings. But now this is all going to be completely different down here. So we have a completely different protein that's going on. So will there be effect? Yeah, totally. A big effect. Right? So this might be our original. And because there's a big effect, it might be this. You'll have a totally different look, totally different than it was before. It wouldn't just be a color change. It might be a completely different limb or lack of limb, etc. Right? So what do we call this? Well, this is a deletion, right? So a frame shift deletion, right? It's not an insertion, but a new one. One of the base pairs was lost, which caused everything to shift over, which is why it's called a frame shift. So in general, right, this is what's going on. We have mutations, so we have beast, and if we do a substitution, right, then we get something that's different, because again, we're reading these DNA, and the DNA codes for RNA, and that RNA codes for something. Well, if that code is changed, then you're going to get a different look. So if you have a substitution, you could get an effect, or you might not get an effect at all, depending on if this codes for the same thing. If we have an insertion, you're going to get something completely different, all right? Instead of having a beast, you're going to have a breast, right? If we have a deletion, you're going to get something completely different, right? Because it's going to shift everything over. So instead of having a beast, you have the best, right? Because something was lost. And then the one we didn't go over was an inversion where they can switch around. So instead of having a beast, we have beats. So these are mutations. So what you need to do now is go ahead and finish this worksheet. So we've already done this one. We've done sequence 1. We've done sequence 2. You have to do sequence 3 and sequence 4 We've already done sequence 5, so you don't have to do that one, right? And you have to do this down here. Okay, so which type of responsible, and answer these questions. Do this, which you know how to do. This is for sickle cell anemia, and what type of mutation is this? So we're going to take our information and apply it to the sickle cell anemia blood cell and see what mutation was made. All right, if you have any further questions, please talk to your science teacher. Have a nice day.